Hello?
Hello.
Hello?
Hello.
How is everybody? So yeah, we're live on YouTube. Little explanation to this. Also, apologies for the quality, by the way. We are in 720p now.
Oh.
Not really much I could do about that. But basically, Twitch has been having issues, and we've been trying to go live for the past 20 minutes now, and we've not been able to go live. So we just said, screw it, we're gonna do it on Twitch. Not Twitch, YouTube, yeah. But how is everybody? Hi, welcome to the workshop. Today we're covering flow and pulses, so I can hand you straight over to Ryuvi, who can explain a bit more of what we're going to go over.
Alright. I'm going to float my way over here. And we're going to cover the flow folder in the Logix node browser. But first, in regards to flow, we're going to be covering all of these nodes, which are located here in the Logix node browser. Here. But there are a couple of components that we're going to cover too in relation to dynamic impulses, which we will cover here as well. And let's start with the components. There's just 3, and they are located. You can go ahead.
Under Common UI and Button Interactions. Now, what this means regards to button interactions, that means these are attached onto button components. For example, if I go to attach component, under transform, interaction, say you add a touch button, and physical button I know for sure uses it, as well as a UIX button. Not exactly sure if the touch toggle does it too.
It might. But when you add a button, if you have a button in a component list here on a slot, and you attach these dynamic impulse components to the slot as well, they'll automatically hook into the button component here, and the button, whenever you press or release the button or whatever, it will send this information here and send dynamic impulses directly. But before we go and show how these components work, we should talk about what dynamic impulses are. But to talk about that, we need to talk about what's a pulse? What's an impulse? Well, in terms of Logix, an impulse is something that does something. It's an event. And I can demonstrate this real quick here by going under Input, Impulse, and spawning this out. This here is a button that has a funny looking white output, which is an impulse. If I pop out a display for this, and I click the button, it's a signal. In this case, from me, one of them, each time I press this, it receives a signal. And this signal can, in essence, propagate throughout a bunch of different nodes to do something. And it's also very colorful when you use a display node on it. Impulses, you can tell an impulse node, or an impulse input or output on a node versus just data, because data inputs and outputs are colored squares, whereas impulse nodes, an input one has kind of an arrow input, and an output has an arrow output, like that.
Wow.
Is that a Fruix I hear?
Yes.
It is. You can also tell the wires for an impulse are a little bit different too. As you can see here, these arrows on the wire are a bit thicker than, say, the arrows on a data line. And ultimately, data and pulses are separate things to be aware of. Now that we know what a pulse is, what a dynamic impulse is essentially a pulse that you can send between Logix graphs, depending on if you want to receive certain data or not. And going right into it, we have 4 Logix nodes under the flow category that deal with dynamic impulses. We have a receiver with value, a trigger, and a trigger with value. And consequently, these receive something with or without a value, or they trigger something, a dynamic impulse, on a certain slot with or without a value. And that comes back to our components over here, because this is literally just a component version of the trigger nodes, the dynamic impulse trigger and dynamic impulse trigger with value. The reason here, though, that there are 3 components is we have dynamic impulse trigger with value and with reference. The one difference between the components here and the nodes is that these 2 here, the trigger with reference and trigger with value, will both get received by a dynamic impulse receiver with value, because it technically a reference is a value, so it gets that associated with it. A quick demonstration of a dynamic impulse trigger would be, let's get ourselves a dynamic impulse trigger here, and dynamic impulses have a tag associated with them. This tag is just an identifier, a string, that any impulse receiver under the hierarchy, the target hierarchy that you choose to fire this dynamic impulse on, any receiver that receives with this tag will send an impulse. For example, if I'm going to fire this into the root slot, and I'm sending a pulse with type tag, if I want to receive this, if I give it, say, tag ABC, then when I pulse this dynamic impulse, it will not receive it. But if instead I give it the tag test, it receives it. And any receivers under the hierarchy that we pulse, in this case it's everything because it's the root slot, all of these will receive this specific pulse event if they have the same tag associated with them. This allows you to have pulses and information get sent between multiple independent logics packs, so that you don't have to have everything in one massive conglomerate logics graph in your whatever it is that you're making. This is very useful also for dynamic things, hence why it's called dynamic, so that you can say your world has some it sends out a pulse for a certain event, and then you can bring something into that world that receives that pulse, and it will start working with it because it uses this tag that it sends out. And dynamic impulse I use them personally all of the time for all sorts of things, especially if I need data that travels between dynamic things that are being created or destroyed at different times. They're very handy. One thing to quickly mention before we move on about dynamic impulses, though, is that if you own a headless client, the headless client also has the ability you can send a dynamic impulse with a certain tag into a world, and it allows you could use that for, say, notify users in a session that the session will be restarting in 10 minutes or something to that effect. So headless clients have this functionality too. Now, moving on to the more general flow nodes. Let me try that again. Most of the useful flow and programming nodes are located under the flow folder in the Logix node browser, as I mentioned earlier here. There's also a subfolder, events, and these events allow you to generate a pulse based on something happening, which I have listed here. A lot of these nodes are self-explanatory, but a few of them, like on activated, on deactivated, and some of these have an input node actually, which if we hover over it, it says only host. If this value is true, then this thing will only send a pulse from the host user in this case. I should also mention that pulses come from a user and they're local only to a user. That's why when I pulse this, and there's Eevee sending test dynamic impulses. Thank you, Wraith. So this is being sent directly from the headless client. But you can see they come from Eevee, the headless user, because pulses are local to a user. If I click this pulse, it says it's from me. But if Aegis clicks that pulse, then it's from Aegis. This is used for local things. Thank you, Wraith, for showing us how to do this on a headless client. But pulses are useful for things that are synced between users and things that are local to each user. Sometimes you might need something to only happen for each one user, maybe the user that's controlling something or something to that effect, then this is an inherent property of pulses. But back to our event nodes. Unactivated and undeactivated will trigger when the slot is activated or deactivated. On destroy and on destroying are for when you're destroying a certain hierarchy or a certain logic's graph. On destroy will fire just before it's going to be destroyed, or essentially as it's being destroyed. So if you want something to happen when you delete an object, you want to use on destroy. On destroying fires literally as it's being destroyed. I personally have never needed to use this node, but it's here if you need it. On duplicate is a very handy node, very important actually for lots of dynamically created things, because this will fire a pulse when this node or the thing that it's attached to is duplicated. This is great for, say you have I don't know, a magic staff that sends out an orb whenever you pull the trigger. You can just duplicate a template, and when you duplicate it, it controls its own path in the world, for example, so you can have a bunch of them going at once. Useful for things like that. And these down here, on loaded, on paste, on saving, and on start, are mostly self-explanatory. On loaded happens when you load the item into the world for the first time. And on saving happens when, I believe, either you save it or the world is saved, or one of those. Now, next up is latching nodes, which there is, at least in regards to these categories that I've created here, these latching nodes, there's only one, but it is a very important node. It is the Boolean Latch. And this deserves a bit of an explanation on its own. So the Boolean Latch node is latching. If you're familiar with an SR latch, it's essentially that. It has set, reset, and toggle inputs, and an onset, on reset, and a Boolean output. Essentially, when you pulse the set pulse here, the Boolean turns true, and it passes through the pulse on onset. And every time you can continue to pulse this, and it will still be true, because all this does is fire onset and set this value to true. Consequently, the reset value turns it to false, and no matter how many times you pulse it, it's still false. The interesting one is the toggle. It will toggle back and forth between true and false, and send out the appropriate onset or unreset pulse. This is good for, say, if you need to toggle something on, or you have a button that toggles on and off, or if you need to do something, you turn something on, and then later on you can turn something off, and you need a value associated with that, as well as further pulses going down the line. Boolean latches are also, I suppose, an example of branching paths, because you have onset and unreset. You can have a pulse go here, and it will output in one of these two locations, which we'll get to later, because there are actual branch programming nodes as well. Next up, we have some delay nodes. And what these nodes do is they, given an impulse and a time, it will delay a value. For an example, if I take the delay node here and give its delay a value of 1, then its impulse here, the impulse output, will be delayed by 1 second. This bottom output is on trigger, which is essentially just, it sends the pulse through, it's instantaneous. I use this many times in conjunction with a Boolean latch if I need to turn it on and turn it off for just a brief period. Similarly, of course, we have a variant of the delay node which has a delay with value, which will, given an input value, it will delay a pulse output, and you'll still have access to this value in case for some reason the value here has changed. And similarly, we have updates delays and updates delays with value. This delays not by seconds, but by updates. It's sort of like frame rate. You can update it by 1 frame, 2 frame, 3 frames, etc., but it's a little bit different than that. But generally, these are necessary if you have very fast timing things that you need to deal with in your code. You can also do the same thing with a value. This one I use in specific with a for loop that I will get to a little bit later. Of course, we've already just covered dynamic impulses, but we have a receiver with value, and a trigger with value. These specific nodes... Thank you, Aegis, for bringing that out. These specific nodes are green in the node browser because when you click on it, it gives you a type that you can choose because you're wanting to choose the type of the value that you're wanting to send through. Say I wanted to send a color value, then I'll choose color, and you can see my input value is a color value. And when I pulse it, it will send this color value through to any receivers that are also receiving both of type color and with whatever tag I set here on the impulse trigger. Going back one moment, this is a node that's not necessarily in flow. The write latch, that is actually underneath actions. We have the write latch and the write ref latch. These are essentially a Boolean latch, except with a write. You can have it so that when you set or reset these latches, it will write a value, either one or the other, to a specific target. Same thing for references here. Also, under the actions node, there are a few helper nodes here which are useful as well. We have the decrement, increment, drive playback, tween, and very important, write, which I will get to these once I finish these nodes down here. Next up, we have impulse generation, and there's a bunch of ways to generate an impulse, but these are a way to create an impulse event from data. And we have the fire on change, true, false, fire while true, and updates nodes, which is a little bit different. The fire on change node, given a value and a user that you want to send the pulse from, it will send a pulse every time this input data changes. An example of that would be if I get myself a float here, and I get myself, let's say, the host user. Now, I should mention you don't have to plug in a user here, but it's generally recommended. Otherwise, it will send a pulse from all users, not just the one that you use here. So, if I change the input value, it sends a pulse from Evie in this case, because Evie is the host user. This is useful if you need to check if something changes at all. Now, say you want to check if something turns true or false, then for Boolean values in specific, this is where these next three nodes come in handy. You can check when a value turns true, when it turns false, and it will send a pulse while it's true, which is a lot of pulses every second. And finally here, for general impulse generation, we have the update node, which what this does is it sends a pulse every single frame, as quickly as the system will allow, it will send a pulse. This is good if you need something to happen every single frame, but do use it carefully, because if you send this into something that duplicates an object, for example, and you're not controlling it as good as you could duplicate hundreds, thousands of objects, and that might be a problem, just as an example. You can also provide to this node like these a user to send the updates from. For instance, if I use the host user, then these pulses come from Evie. Similarly, these are impulse generation where you can provide a user, but if you want something to happen locally for each user, we have local impulse generation nodes as well, which what these do is, for instance, if I'm checking if a value is true for me, then I'd want to use the local fire on true, because if I fire this, everyone sends a pulse when this value becomes true, because for them locally, this value has become true. This is useful if you're driving things that are different for each user. Say a HUD or something that has your local information on it. For me, it would say, right, UV. For Aegis Wolf, it would say Aegis Wolf. maybe something on there has a value that locally turns on true only for me. This is how you can check that only for that specific user. Now, continuing on, we have branching flow, which this allows you to have conditional statements, for loops, while loops, sequences, and to have random pulses. If statement is pretty simple, but given an input pulse and a value, a Boolean value, a true or false, it will either send the pulse here or here. This is useful if you want to check if something is true or not. Say I'm creating an event for an object and I want to check, hey, is some condition true or not? If it is true, do something, otherwise do nothing. So for instance, say maybe it's an object and it's this template object, and if you want to duplicate an object but you don't want to touch the template, because if you mess up your template you won't have an object anymore, you can check, is it the template? No. Is it the template? True. Then in this case we'd want to, is it the template? Yeah. Do nothing because it's the template. Otherwise, do something. Like so. Similarly, we have for loops, which a for loop, given a impulse and a number of times you want to iterate, and if you want to do it from backwards instead of forwards, you can cause something to happen. And you get a lot of pulses from a for loop. You get a pulse when the loop starts, for each iteration of the loop, and when the loop ends. You also get the current iteration number that the loop is at. Now, one thing to consider about the for loop and the while loop, and the rest of these in this case, is when I pulse this, let me just say, let's do it once. You might think there might be a time difference between these, but when I pulse this, they all seem to happen seemingly at the same time, but that's because the entire loop, all of its iterations, will execute essentially all at once. However, there is still an order. You can see that our loop started at 81. It fired for this one loop at 82, and then the loop ended at 83. So there is still an order here. An example of this would be, say for each loop I want to add a number, which that is what this node does. This adds 1 to a number value. Let me get us a value that we can actually add 1 to. An integer, for example. And let's set this to 5. Then for each of these it will add 1. And of course by the end of it I have 5, because it looped through this 5 times. This is especially handy if you are, say, getting slots in a hierarchy. You can get the children count of a hierarchy, and then you can get the child, and you can get a specific child in the hierarchy by using the iteration number here. And of course, for using children count, it will go from 0 to however many slots there are. Then you can plug in the slot that you're wanting to get the child from, and now you have access to each of these slots individually, and you can do something with that. Now, going back a moment, I mentioned how updates delay with value is useful in cases like this, because say you're doing something that manipulates the slot hierarchy. Let's say we have a slot here, and it has 3 child slots. Then if I were to say, oh, I want to go through here and delete certain slots for certain reasons, and let's say I get rid of slot 2. Well, then as I'm going through here, it will go slot 1, slot 2, delete it, and now there's only 2 slots here. So it will go through and, well, there's no slot 3 anymore, so nothing will happen, and it can essentially, it can break how certain things work. So if you're manipulating the slot hierarchy itself, whether, the number of slots here, whether you're adding or removing slots, something I would recommend is using an updates delay with value. You can plug this in, plug in your slot here, and you don't need to provide a value because we just needed to wait once. What this will do is this will kind of pool up a bunch of pulses based on all of the children that it's receiving here. And then once the whole loop ends and you've gathered up all of the slots that you want to do something with, then you can say destroy slot, or whatever it is you need to do after the fact. And this will guarantee that it will say destroy all of the slots in the hierarchy instead of, say, just half of them in this case. It's a little tidbit, very useful, and it works for loops and potentially while loops as well. Which, moving on, speaking of while loops, for loops are useful if you have a set number of things that you want to go through. A while loop, on the other hand, will fire these loop start, iteration, and end while a condition is true. So say you don't know the number of slots that you want to delete in a hierarchy, for example. You don't know how many you want to remove, then you can use a while loop, and you can say, oh, while there are nodes here that I want to delete, then delete them. Now, going on, we have sequence. And the sequence node, given an impulse, it will, one at a time, although like the for loop, instantaneously, send this pulse here and then here, like so. And like previously, they have an order. This one fires ultimately before this one, and then the third one here fires before these two. So there is still an order, and one thing to mention is, with the sequence here, everything that's connected to the first point will execute before everything executes here, and so on and so forth. It kind of goes like group execution. So this pulse, it seems like it might have like a time duration between, but really what you're doing is you're executing everything after it essentially all at once, unless you include delays and such. And this allows you to do something in a specific sequence if you need to. And similar to sequence, but not quite the same, is pulse random. What this will do is, given a pulse and a set number of outputs, it will send the pulse to a random one of these. Like so. Every time I click this, it sends the pulse to one of these random outputs. Also useful for things if you need something to randomly happen. But moving on, we have multiplexing flow. And similar to the multiplex and demultiplex value nodes, given that you can choose a value depending on which one you want, or you can send a value to a certain output depending on which one you want to send it to, the impulse multiplexer and demultiplexer are very similar. You can choose an impulse, and you can choose which output you want to send it to. This one, or however many you need to send it to in this case. And similarly, of course, we have an impulse demultiplexer, which takes any number of pulses, and it sends it through, but it also sends you through the index which one of these pulsed. So you can say you receive 4 different events, you can do something based on which one of these events triggered. And finally, we have rate control. The rate control ones allow you to control not only how quickly pulses are sent, but also you can generate pulses based on certain times. Once per frame, for example, if you receive a ton of pulses all in one go, it will only send one out every frame. This is useful if you have lots of data coming in, but you want to limit it to just once per frame. Hence the node. And we have timer, which, given a time interval in seconds and a user, say I'll put this at 1 second, it will send a pulse every second. I set this to, say, 0.4, and it sends a pulse every 0.4 seconds. Say you need to do something every 5 minutes, then, 5 minutes is 300 seconds, then this will send a pulse every 5 minutes, for example. I use this node a lot, it's very handy. Also, if you don't plug in a number, it's 0, so it's every frame, essentially the same as the update node. We also have the local Leaky impulse bucket, which is a funny sounding node, but what this does is, given a bunch of impulses in here, or that you're sending to this thing, you can give it a capacity, say 5, and an interval, let's say 0.3. Then when you pulse it, it will send it through. But if I pulse it a lot, you'll see it's only sending them out at the set interval that I'm choosing, in this case 0.3 seconds. So if I really spam this, it only comes out every 0.3 of seconds. But you'll also see that if I spam it really quickly, if I really go, and you can see it overflows, and anything that's above this value that hasn't been sent out yet will get sent to the overflow. This is good if you need to rate limit something. If you're gathering up a bunch of pulses, it's almost like traffic, where you've got a bunch of cars lining up at something, but only a certain number of cars can come out at a time. It's like a leaky bucket. I haven't personally found a use for it in my programming, but I can definitely see the use for it, and it is a node that I definitely recommend looking into. It also has a reset if you need to reset the capacity and such. And we also have local impulse timeout, which, given a timeout time, say 0.5, then I can send a pulse here, but it will only allow a pulse through every 0.5 seconds in this case. So if I really spam it, the pulses only go through at my set speed here, the timeout. Also very handy. And finally, up here, I briefly touched on it here on the earlier, which was the increment nodes. We also similarly have a decrement node, which this adds 1 to any number that you're referring to here. This subtracts 1 to any number you're referring to. We also have nodes which allow you to control something based on whatever it is you're wanting to do here. Drive playback, for example, is meant for driving anything that is a playback, which is audio, animation, things like that. You can start and stop it. You can control where it's normalized position from the start to the end of whatever it is, be it the animation or the audio, as well as other things here. You can play it, you can loop it, all sorts of things. Similarly, we have a general drive node, which, given a field you want to drive, you can start and stop this driving dynamically here. You can control when that happens, and so on and so forth. Now, if you want something to, say, animate along a specific kind of curve from a specific value to another value over a set duration, you can use tween. And there's actually a lot of things that use tween. An example is any menu that kind of slides back and forth like this. It's taking this panel and tweening it, sliding from here to here over a set period of time. Of course, you can use tween for any value. That's what these purple value or these magenta values are, the dummy values, meaning you can plug whatever value in there you want. You can also provide to it a curve, whether you want it to interpolate or move between the two values linearly, with a sine curve, cosine, smooth, smoother, and so on. And of course, one of the more important nodes, I would think, if you need to store data, or if you need to update data at a specific time, you can use the write node. Which, for an example, let's get a float here. And I want to write to this float. And if I check this thing's value, let's say I want to write, say, 9.5. Then when I send the pulse through, it stores that value in this value register. But this can be anything, really. Like over on this slot over here, I can grab this position. Let's say I want to write to the position. Let's say I want to write 101. Then when I pulse this, the position of this has changed to 101, or somewhere over there. And there's a lot of any node that requires you to do something generally uses impulses or flow. It requires flow. For instance, if you're wanting to set the global position of something, you'll see it takes an impulse input and it fires an output on done, so that when it sets the position, in this case of whatever slot you're wanting, the impulse will continue and you can do something else. And similarly, if you just plug in the slot and the value but don't pulse it, then this node will do nothing until you give it an event or an impulse. I think that pretty much sums up a lot of these nodes. They all have their use cases, but from here we can cover a few examples of how these nodes can be used. Aegis, would you mind showing us some examples?
So, first one that popped into my mind that is more of a thing that we made on stream in the past is some of these weapons that we've been working on for users to learn how to use different types of logics and components to make something like this, or a custom tool as well too. So you can see where it takes like this raw data tooltip and takes that impulse. Say when you press the trigger, it uses like a raycast, it shoots like a laser in front of it, and actually uses the impulse demultiplexer. And it does something different depending on if it hits something or if it doesn't hit anything as well, using that integer value.
One thing I will mention real quickly, since we're on the topic of this and we covered this earlier, is this value. If you try and look at this value by just pulsing these, you won't see it, because for the for loop and for this and for other nodes, this value only exists while this pulse that's coming out of it also exists. So you either have to write this value or use it immediately, which
It's
in
the
this
same
case,
thing with any
you are
one of
using
these
it immediately.
values right here. Actually, yeah, even the triangle index.
So those values are not persistent. You either use them or write them to store them later. But go on.
I believe this also has several other... yes, the decal. So when it hits like a target or surface, it leaves like a little 8-bit looking decal. So if I go into here, unhide the decal, and go into the decal logics and unpack it. Okay, good. It's not obscured. Okay, I can still see it. This also shows the onduplicate. And there's a template object. It's hidden within, and it has all this logics packed in. When it shoots and hits a target, sets the object non-persistent, so even if the world gets saved, it will not save that little decal in it, and even if the decal's logics fails to delete itself, it won't save either. So right here you see on duplicate, and it turns on this Boolean latch, which activates like the actually two Boolean latches. Just place around with the effects here.
We actually have a comment by Paragon of Insinuation. Logic updates are less than a frame, so it usually goes away before the next frame is called to render. Yes, this is true. And that's why these values need to be used or written as soon as possible.
Is there... What else do we got here? Well, that's tooltip events.
That's why I have this handy tool.
Oh yeah. This community-made tool, which allows you to list values.
So you have like a plug-in here, and then...
Yeah. When basically, because obviously of how quick impulses come through, this will actually show you the impulses.
It'll list them out, and it'll tell you the value that it received when the pulse went through, if you need one, and so on.
Yeah,
It's a very nice tool.
Yeah, it's a very handy tool that was created by the autopilot.
Very nice.
So, as for this little contraption here, when I click on this button to generate, it randomly generates procedural meshes, boxes, and puts them in a nice little glass box. Kind of like a random generated art thing. And what this is using is a for loop, if I recall. There we go. 3 of them, actually. Or no, 4. 4 for loops. And the for loops, each of those iterations, how many times it fires, is actually determined on how many boxes that you input in here. So you can actually have like a menu to interface with it too.
We could see for each iteration it duplicates a slot, sets its parent, and does other things, and it does this any number of times, at least for the values that you've set over here. Which, that is a good point of interface cards here, is that you're pulling this value from outside of logics, in this case from a button, so you use the value as the input, the iteration count for a for loop. And when this is generated, you'll see that it generates nigh instantly, because all of that happens all at once.
And it takes a little delay at the end to kind of wait in case if there's like any lag or anything, and then bakes it all and sets the parent to the root. And now, bakes it all into one mesh.
And just for this specific thing, this is available in your folder in Essential Tools, correct?
Yes. As you can see, the mesh is baked now. I have several different generators like this.
Paragon of Insinuation also mentions something else that is, I think, should be mentioned here, and that is that data and impulses can be split in essence, or he says here the splitability, whereas I guess an example of this would be if you have a, so we could just get an add node here. If you have a data input, you can send the data input to multiple. You can send this data to multiple data fields at a time, like so. However, you can't send 2 types of data to the same field, like here. Now, different from that is pulses. So, with pulses, if you have 2 different pulses, you can pulse the same thing from 2 different locations. However, you can have pulses go like this, or to the same location, unlike data, where it's only one.
Like having multiple different events that do the same thing in the end.
Another thing about pulses is, unlike data, you can have data which can go to multiple fields at the same time. A pulse can only go to one place at a time, but it can go to the same place from multiple locations.
And say if you wanted to go down, like do something that does the same thing as this, you would probably have to do either like a sequence or have like, well, as you can see here, it goes from step 1 to step 2 and onward.
Yeah, there's a bunch of ways to do that, but I generally use a sequence if I need to see when this pulsed or have this do multiple things at a time. A good thing
it's a matter
to
of
keep
organization.
Okay. Well, how about the big old car you have over there? We also have some examples over here.
So, for example, the logics here is the logics for the doors to open them and close them. So not only it's using a UIX button to open and close the doors, there is a button outside and inside the car to open doors. It also plays a sound effect when it opens and closes as well. So I have both of these buttons per door.
The inside and outside buttons, I presume?
Yes. Yep.
Button.
Taking on pressed into an if node, and it basically stops you from pressing that button if the animation or audio clip, in this case, is already playing. And I also have that plugged into the audio output, so if the audio isn't playing, then the audio output is disabled as well too. It goes to a Boolean Latch here, which toggles the door animation, which is just simply using value gradient drivers. Those are really, really good components. You can do
And
a
you're
lot
toggling
with
it because you might want to open or close the door, whether you're inside or outside of it, which is a good use of the Boolean Latch. It turns these buttons into toggles instead of just one turn opens the door, one closes the door.
Now, since we're here, can look at the update node and what it can be used for as well too. So in this case, let's look at the rotation. And what I mean of rotation is how the car turns, left and right, or tilt, depending on what it is it's doing. So, a lot of this is a lot of different dynamic variables, different data kind of inputting into how the car is supposed to tilt, turn, and rotate. And way up here is the update node. So this has, like, of course, the user input. And what it's doing, it's taking the anchored user, which is the user that sits in that car, and as soon as it starts the simulation off of the anchored user. And it's writing all this data here too for rotation.
Very nice. And this works because you need something to happen every frame, so therefore you use the update node, which sends a pulse every frame. Okay. Since we started late, I'm not sure how we are on time, but I think this pretty much covers the basis of this. If anyone has any questions about these...
52 minutes so far.
If anyone in chat has any questions, now is the time to ask them. And yes, it just does make some pretty awesome vehicles. I wish I could see a viewer count.
I can look at the 15 right now.
Okay. We also have a Fruix over there. He's not in his spot.
I was gonna say he's hiding over there.
Yeah.
Hey,
Hold on.
Fruxius.
Oh, okay. I was gonna drag him here.
Wow.
Hi, Fruix. How are
There he
you?
is.
Hello, dude.
Hey,
Hope you're
Fruix.
well.
Twitch sucks.
Or,
Oh.
That was really annoying because it's like, why is it not working?
Mm-hmm.
Yeah. Well, at least you found the tweet that they got about it. So
Yeah.
And We can stream to YouTube.
I was going to say, it's nice that we did have the backup of the YouTube, yes.
And no more exclusivity too, so... As
Yeah.
of, I think, yesterday, actually.
Oh?
Nice timing, I think. It was like for a Twitch partner or something like that.
Oh, so we can now upload instantly.
Oh.
I'm
we can
not
stream
sure exactly
or
on
we could stream to both
that.
platforms, more to the point.
Wait, did we get a partner?
No, we're not
No,
partner, we're an affiliate.
Oh. Wasn't it just for partners?
Yeah, the stream is supposed to be unlisted, yeah, it was quickly done, so...
Okay.
As I say,
Yeah,
I
the
didn't really
stream
get
will
much...
be-
I didn't really get much time to set everything up ready for us to be on YouTube, so... But
Well, hey,
hopefully,
you did it.
yeah, we'll be back on Twitch. We'll be back on Twitch in 2 weeks, and we'll be back on Twitch on Friday.
And of course, like always, this world will be open for an hour afterwards. If you'd like to come visit, come say hi, come ask about nodes, and all that jazz.
Yeah. Join the cult.
What?
Join the cult of the yellow dog man.
What? Oh, cool.
I've been playing too much Cult of the Lamb.
I've seen a lot of people playing that.
Yeah,
That game reminds me of Paper Mario for some reason.
yeah. I actually have a thing called the Cult of Yellow Dog. And the funny
Good.
thing is, Fruix is actually in said cult.
Oh,
I remember, like, last time I was checking the Twitch thing, you can, like, make your own little character, and then, well, I'm running around in there, too.
Yeah, I really do like that game. It's really cool. It's given me a few ideas and a few things I'd actually want to see done in Neos now. Like, get little mini-games.
Minigames would be nice to have going forward.
Yeah, I just
Which
need to
plays
sit
Neos?
down and actually figure it out, because I don't have a clue how to do something like that in Logix, so it's going to be time for me to learn. Because this is actually going to require me to use some of the impulses and all this lot that we've actually covered today, funnily enough.
Well, it's good that we covered it.
Yeah.
Mm-hmm.
We've still got quite a few other bits and pieces we want to cover as well. I know we still need to go over facets. And how to create facets, which I do believe we've got planned for our next stream, actually. I think. I think we actually agreed on that one.
Yep.
Yeah, I think it'll be a good one, so we can get it done.
Yeah, so... Workshop in 2 weeks, we're going to teach you how to make facets for your dashboard.
I do have one in my folder as well. It's just some abstract-looking binary clock.
I could start that all day.
Hey, there is a question. Can you extract/detect if a user clicks an object, like holding and pressing the trigger? I'm pretty new and wanted to make a toggleable flashlight with different modes.
Absolutely. You can detect when a user presses a button. There's multiple ways you can do that, but essentially you can get a pulse from a specific user. In this case, the one who is holding the object and press the button, because pulses, like I mentioned earlier, are local to one user, the user who did the event. So you can totally do that. Yeah, like that. You're pressing secondary, but I could press secondary all I want. It won't do anything because Wraith is the user who's causing those events.
Yeah. Papa. You know what?
I also have that tooltip.
Spooky.
Also, if you hold down trigger with the old spotlight tip
Yeah.
and dim it.
Are you scared? How about
I mean,
we
I
tell
can
you
add
a
some light to this
story?
Crooks spotted.
Freaks spotted.
oh,
Light.
Let there be light.
Also, I'm really liking that.
Oh yeah, I wonder how many people noticed my little desk ornament.
Yeah. Actually, I'll tell you what. Before I start coughing everything up.
Oh. Camera's on you.
Well, it's on me in the third person. There we go. There's the little desk thing.
Spinners, which we covered
Spin-
before. There's Wraith. We can't hear you, Wraith.
You can't hear me. I had to mute my mic because I was... my throat had started hurting.
Aww.
Mhm.
But yeah, our little Workshop Wednesday desk ornament.
Mm-hmm. I totally didn't make that in 5 minutes before the stream.
It's actually a neat shot, too, like, for a camera angle as well.
My man's using a missive eye tracking. My man doesn't mess around. Gentle Sav.
Wait,
I wish I had more time to really dive into Neos and Logics. The public items I fiddled with months ago got me itching to make all kinds of things. Well, make all kinds of cool things.
Yeah.
As they say, no time like the present.
Mm-hmm. And if you need help, you can always join this session and ask our mentors, and there's the Helping Questions channel on the Discord too.
Indeed. And we're gonna, as I say, I'm not seeing any more questions, so we're gonna call it there.
All right.
So I would like to say firstly, thank you once again to Aegis and Ryuvi for teaching you guys how to do the input, the pulses and flow stuff today.
Mm-hmm.
So it's goodbye from me. Bye-bye from Ryuvi.
Bye-bye.
Bye from Aegis.
Take
And
care.
say goodbye, Yellow Dog Man.
Wow.
No, you're supposed to say bye.
Hello.
We should add an anchor where that little desk ornament is.